Hello friends, in the current video tutorial I will be talking about using logarithmic scales to plot data on waveform graph in LabVIEW. So let's get started. Logarithmic scale is beneficial to use when the range of values to be displayed is very large. Supposingly we have a data which is ranging from sub-zero values to multiple tens and thousands and millions and billions of values. So such type of data is having very wide range. So we have to use logarithmic plot to plot that data. So in waveform graphs in LabVIEW, it is inherent by design that we have to display evenly sampled measurements, meaning it is assumes to be having increments in a regular equal spacing along the x-axis. So by default we cannot use x-axis for plotting the logarithmic data. So x-axis has to be plotting those data points which are consistent and are equal in increments. So we cannot have logarithmic scale on the x-axis. However, we can have logarithmic scale on the y-axis to plot the logarithmic data. So now let's see that how plotting data having a wide range is beneficial to be plotted in the logarithmic scale. So I have generated a random, not a random data, I have generated a data which is exponential data, which is increasing exponentially, and that is going to be plotted on waveform graph 1, which is having logarithmic scale on the y-axis, and waveform graph 2, which is having normal scale without logarithmic on the y-axis. So now if I run the plot, you can see the benefits. So the same plot, you see we have the same plot to be plotted on waveform graph 1 and waveform graph 2. So as you can see that the graph in red that is plotted on the normal scale, right? So you can see the cramping over here. See the cramped data values. You can't read anything, you cannot get anything, right? And the same is plotted on the logarithmic plot, and you see the values are increasing exponentially. See, the values are increasing exponentially. So such type of data is to be plotted, then it is much beneficial to see the graph in the logarithmic fashion. Now how to make the scales logarithmic? So you have to right click, go to the properties, and on the scales select Y scale and select log. You have to change the auto scale, and you have to plot the minimum values and the maximum values. I'm starting the minimum value to be 1. I can change it to be 0.1 also. So when I change it to 0.1, so that makes the plot a bit more clear. And over here also I can save this, and over here also I can make the plot a little bit better by making this value as minus 0.1. Still no effect. Let's make it minus 100. Not much effect. So you can't do much over here because the values are cramped at the lower end of the scale. So even if you say minus 1000, then also the values will have no effect. So this is the difference between logarithmic plotting and simple plotting on the Y scale. I will show you another example in which you can see the range of values which are ranging from micro level to mega level to giga level. So those values are also represented better on the logarithmic plot. So now you can see that some values which are ranging between a large range are being generated. These values having different uh, ranges, they are plotted on the waveform graph. Uh, the range of values are very different. They are ranging from micro level, see this is micro level, to the mega and giga levels. So this is the sample on the x-axis, which are evenly sampled values, and the range of values is too big. Imagine micro level to mega to giga levels. So if you have to plot such a data, you have to use for sure logarithmic plot. And if I run this, see the values, micro level values, milli level values to tens and thousands and millions and billions levels. So much mega and giga levels. So much wide range. If you try to plot it to a simple graph, waveform graph, if I plot it on a simple waveform graph, what will happen? So I take a waveform graph and I don't do any scaling here, everything is auto scaled, and I try to plot these values over here by joining this graph. This graph is totally without any logarithmic changes, simple graph. So when I run this, see cramping at the lower end and too much big peaks. So you cannot get anything from these graphs until they are logarithmic on the y-scale. So that comes to the end of the video. I hope you have understood the concepts properly and you have liked this video. Thanks for watching this video and come again.